Okay, hi guys, so we'll be continuing on seeing more on the calculation of pH. So let's say we have a compound which is a weak diacetic base. Okay, so we have Ka1 and Ka2 as the ionization constants for the 2H plus. So let's begin with the first removal of H plus from this compound, rather the addition of H plus on this compound. This is a base. Okay, so this is in aqueous phase reacting with H2OL, forming then NH2 CH2 NH3 plus aqueous. Okay, and the same compound, after getting attached with one H plus, again in the second step reacts with H2OL and forms NH3 plus CH2 NH3 plus aqueous. Okay, so at equilibrium we can write that, let's say initially C was the concentration and final at equilibrium concentration is C minus X. X is the concentration of this compound formed. Then out of this X, let's say Y got dissociated to form Y amount of this compound at equilibrium, and to maintain the homogeneity of simultaneous equilibrium I have to add X minus Y here as well. Okay, now comes the conditions part, that if this is this is not Ka, this is Kb and Kb1 and Kb2. So if Kb1 is greater than Kb2, then we can write, or rather then we can neglect Y with respect to X. Okay, again why? Because as this reaction goes in forward direction very less, so this means that Y upon X minus Y quantity would be very much lower than X minus Y upon C minus X, which is nothing but Kb1 and Kb2. So this quantity would be very much high, and owing to the fact that this would be very much high and Y would be small, so this implies that X would be greater than Y. Okay, again erasing it because this was just for the explanation purpose. Okay, next we can neglect Y with respect to X, so we can write Kb1 as X square upon so by the way, one OH minus is also formed here and one OH minus aqueous is also formed here. Forgot to write that. Okay, so this would be formed as X, and Y amount of OH minus would be formed here. So this would be nothing but X square upon C minus X, and Kb2 would be Y square upon X minus Y. So this would be just the Y square upon X. Okay, so the amount of OH minus, the concentration of OH minus can be written as X plus Y. So this would be X plus Y, this would be Y plus X. Oh, I think I have written something wrong here. So this would be X plus Y. So Kb2 would be X plus Y times Y divided by X minus Y. So X minus Y and X plus Y get cancelled out, so this should be Y. Okay, so OH minus concentration would be X plus Y, and this would be nearly equals to X, as Y is negligible with respect to X. So here also first step decided how much basic solution would be formed. First step is the decider step. Okay, next let us go to another important topic, which is salt hydrolysis. Okay, so if cation or anion or both ions of salt reacts with water, then the process is called as salt hydrolysis. Okay, so if cation or anion or both ions of a salt reacts with water, then the process is called salt hydrolysis. Okay, next we'll be seeing types of salt. So first is a normal or complete salt. Okay, so this is formed by complete neutralization of acid and base. Okay, and salts of monoacid and other monobasic acid and monoacidic base are complete salts. Salts of monobasic acid and monoacidic base are complete salts. So examples of the same can be NaCl, KNO3, NH4Cl, HCOK, and CH3CONA. Okay, another type of salt is salts of polyprotic acid and monoacidic base, or monobasic acid and polyacidic base. Salts of polyprotic acid and monoacidic base, and salts of, or you can write monobasic acid and polyacidic base. And examples of the same can be written as Na2, C2O4, Na2CO3, Na3PO4, Na2S, MgCl2, ZnNO3 whole twice, etc. Okay, next type is we have incomplete salt. So this is formed by incomplete neutralization of acid and base. Okay, so we have acidic salt, which is NaH C2O4, NaHS, NaHCO3. So these all are formed by incomplete neutralization, hence incomplete salt is their name. NaH2PO4, Na2HPO4, we can also have NaH2PO3, etc. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on types of salt. So till then, good luck and goodbye.